And probably look at it before the homework. Okay. So, what I mean by this, a rational function is of the form polynomial divided by polynomial. And this means generally different polynomials because it's the same polynomial. It's not very interesting because it just reduces to 1. Okay? And any polynomial, as you now know, if you understood everything in the homework, and if you didn't, I'm just going to state it right now. It's a product of linear factors like the ones we've been looking at, right? And irreducible quadratic factors. I don't want to write down irreducible, but implicitly these are going to be irreducible. If they aren't irreducible, the quadratic formula will tell you, and you can reduce them, right? Okay? And an irreducible quadratic is one that doesn't have any zeros, one that can't be expressed as two linear factors. Okay? So, whether you totally understand why that is or not, and you know, it's noon, so need time to sort it out. Let's just look at an example. Now you've had examples, okay? I gave you examples on, I think the homework assignment was due today, or maybe it was earlier because I think I've seen it. And you did fine with it, where you had also denominators, right? You had like an x minus 5 in the denominator, and you're just determining where it's positive and negative, right? Well, any zero of the numerator or denominator is a it gives you a point of a partition of the x-axis. And the pluses and minuses are determined the same for rational functions as they are for polynomials. You just determine whether each factor is positive or negative. And on each interval then, on each interval, you determine whether each factor is positive or negative. And figure out whether the graph itself is going to be above or below the axis, okay? Right? So there's no difference for rational functions, but the difference as far as where you have positive and negative and how you find them, okay? If it's an irreducible quadratic, then it's either positive or negative everywhere. Linear functions positive to one side of the zero, negative to the other side. Okay. So just an example, let's take x minus 3 times x plus 4 over x minus 1. Okay? And we only have to look at the zeros of the linear factors as long as we're sure all the quadratics that can be reduced have been reduced to linears, okay? Now the only quadratics we have left are ones that are either vertex above the axis opening upward or vertex below the axis opening downward, okay? So the zeros of our linear factors are 3, 1, and negative 4. So we can partition our axis. We've got negative 4, we've got 1, and we've got 3. Okay, to the left of negative 4, all three are negatives. So we have negative, 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 giving us a negative. Between negative 4 and 1, just doing these in the order, this one, and then this one. This one is negative, this one is positive, and this one is negative. So we have a positive. Between 1 and 3, well, this one is still negative, but the other two are positive. So we have negative, positive, positive, which gives us a negative. To the right of 3 is positive, 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 so we have positive. Okay? Make sense? And if it doesn't, you know, keep practicing. You can do it. Everybody's on the verge of doing it if they don't quite have it. Okay? And some people look like maybe they have it, but I can't tell because they didn't tell me enough. Okay? Can't tell whether it was luck or skill in some cases because there's not enough documentation. Okay, so that's it. We know where this thing's positive and where it's negative. That was easy, right? I mean, assuming you know the process that you'll know by Tuesday if you don't know it today. It's easy to do that. Now, the other thing is, for a rational function, these are not all going to be zeros. Okay? So we want to talk about that just a little bit. So we want to talk about what happens when you divide something by a small number.